In this table, there are some examples of 0-degree polynomials. A 0-degree polynomial basically means that there are 0 x's, so it's just a number, like -14. A first-degree polynomial is a linear. That means there's just a plain x. That x does technically have an exponent of 1. A quadratic has an exponent of 2, a largest exponent of 2. A cubic, the largest exponent is 3. Quartic, the largest exponent is 4. On these examples, we need to decide, first, is it a polynomial? So does it follow the rules of polynomials? Then, so the first thing is it a polynomial? If it is a polynomial, we need to write it in standard form. Then we need to state the degree, the type, and the leading coefficient. So for A, first we need to decide, is it a polynomial? Take a look at 5, -2, and 8. Are those all real numbers?
Yes.
Yes. Look at the exponents. We've got 1 and 3. Are those all positive whole numbers?
Yes.
Yes. So yes, this is a polynomial. Next, we need to write it in standard form. So start with your f of x. Which term has the largest exponent? -2x cubed, that's our first term. Then we'd look for x squared. We don't have an x squared. Then we'd look for an x, so plus 5x. And then the number is always the last one.
That's it?
Yep, write it in standard form. Just put it in order from largest exponent to smallest exponent. We are looking for the degree, the type, and the leading coefficient. The degree is the largest exponent. So what is the largest exponent here? 3. For the type, if you go back up to this chart, the type is linked to the degree. So if it is a third-degree polynomial, that means it is a cubic. So for type, we would write cubic. The leading coefficient is the number in front of the term with the largest exponent. So what is our leading coefficient? -2. And you can use LC for leading coefficient. You might want to write in there that when we use LC, we're talking about leading coefficient. Take a look at B. First, is it a polynomial?
No.
It is a polynomial.
Unfortunate.
I put this one in on purpose because this is the square root of +2. That is a real number. That is totally fine. -0.8 is also a real number. The exponents are 3 and 4. Those are all positive whole numbers. So yes, this is a polynomial. It's a little bit weird that we've got the square root in there, but whatever. Write it in standard form. What's the first term we need to write?
The square root, 2x.
Square root of 2, x to the 4th. Then minus 0.8 x to the 3rd, minus 12. Okay, what is the degree?
Yeah.
The degree is 4. The type?
Quadratic.
Close. Quartic. And the leading coefficient is the square root of 2. Okay, look at C. Is C a polynomial?
No.
And because I know you're all going to look back at your notes anytime you forget something, because that's the first place you go when you are struggling, right, is back to your notes.
Yeah.
Some of you are like, absolutely yes, and other of you are kind of laughing right now because you know that's what you're supposed to do, but you don't. But some of you do, so yeah, that's good. So just in case you are going to look back at your notes, you should probably point at that -1 in the exponent. You can't have negative exponents. How about D?
Yeah.
No, because you can't have x as an exponent. When we evaluate polynomials, this is just plugging in a number. So they're telling you x is 3. We need to evaluate the polynomial when x is 3. This f of x thing, this means f of x. It is a label. It's saying that we're calling this function f, and this function uses the variable x. So if we evaluate for x equals 3, we are finding f of 3. This does not mean f times 3. It doesn't mean that we need to divide by 3 at the end. It is a label that says we're taking the function f, we're plugging 3 into it, and then on the other side we'll put what the answer is. I am going to strongly recommend the use of parentheses. Anywhere you see an x, put parentheses directly around it and then put the number inside there. So 2 parentheses 3 to the 4th minus 8 parentheses 3 squared plus 5 parentheses 3 minus 7. If you go a little bit overboard with parentheses, you can plug this in one line into your calculator and get the correct answer. So take a moment and try that.
Bless you. Bless you.
If you got 98, you punched this into your calculator correctly. F of 3 is 98. That statement means we took the function f, we plugged 3 into it, and we got 98 as our answer. The parentheses are especially important when you're plugging in a negative number. And this one is a little bit weird because there's a negative in front of the x to the 3rd. So on this one, you really, really need to put parentheses directly around each x and then put the -4 into that. So I am going to do g of -4, negative parentheses, -4 to the 3rd, plus 3 parentheses, -4 squared, plus 9. Now, theoretically, you could use order of operations and do this piece by piece in your head and get your answer, but the number of opportunities that you have to make a mistake are high. So if you use the parentheses and plug it into your calculator, you should be good to go. If you get 121, you did that correctly. Next, we need to talk about end behavior. Tomorrow, we're going to start graphing polynomials, and the middle portion gets kind of crazy. If you have something like x to the 5th, there's a lot of like humps and bumps and hills and valleys in between the two ends. But we can use the degree and the leading coefficient to tell us what the ends of the graph are going to do. And I want to start by talking about the leading coefficient. The leading coefficient, remember, that's the number in front of the term with the biggest exponent. If the leading coefficient is positive, the right side of the graph is going to point up. And notice down here, leading coefficient positive, the right side of the graph points up. When the leading coefficient is negative, the right side of the graph points down. So whatever the leading coefficient is, that's the behavior of the right side of the graph. Positive leading coefficient points up on the right. Negative leading coefficient points down on the right. That's the first thing that you need to memorize. The second thing you need to memorize has to do with the degree. If the degree is odd, I want you to write down odd opposite. An odd degree would be like x to the 3rd, or x to the 5th, or x to the 7th. If that largest exponent is an odd number, it's an odd degree, and the end points in the opposite direction of the right side. So when we add the negative leading coefficient, the right side points down. Odd degree, the other side's going to point up. It's the same with even, or it's the opposite of that with even degree. If our degree is even, even points the same. So you should write even, same. If the degree is even, the left side will point in the same direction as the right side. So first thing you need to memorize, leading coefficient, positive right side up, negative right side down, odd opposite, even same. So let's look at these problems. And it says that we need to make a sketch of the shape of the graph. Basically, I want the two arrows representing the ends. So this one, first let's start with the leading coefficient. Our leading coefficient is negative 0.5. Is negative 0.5 a positive or a negative number? Negative. That means the right side is going to point down. So give yourself a space and then draw a down arrow. Then we look at the degree. What's the degree of this one? The degree is 4. 4 is an even number. Even degrees point in the same direction. So the left side will also point down. Now, we have no idea what kind of crazy stuff is going to happen to connect these two arrows. It could look like something super crazy, but that's not what we care about right now. Right now, we just care about what are the ends of the graph doing. Now, why do we care about this? Let's say on a test, I give you a polynomial and I give you 5 different graphs and I say, which of these graphs matches this polynomial? If you can look at the leading coefficient and the degree and figure out that both ends are supposed to point down, you can find the graph where both ends point down and pick that out as the correct graph. So we'll fill in the middle stuff later. For now, we're just focusing on those ends. Okay, the next one, the leading coefficient. Is our leading coefficient positive or negative? Positive, that means the right side points up. What's the degree? 3. 3 is odd. Odd opposite. So the left side is going to point in the opposite direction. Left side down, right side up. Okay, if you're watching the video, pause the video, try C and D on your own.
Yeah, a little bit too quick.
Okay, leading coefficient does the right side. Degree tells you if the left side does the same thing or does the opposite thing. I may also on the test give you problems like example 4, where I give you a picture of a graph and say, what would the degree of this graph be? What would the leading coefficient of this graph be? So first let's look at the right side. Because the right side points up, what do you know about the leading coefficient? So positive leading coefficient. And then the left side is pointing in the opposite direction. So what do you know about the degree? The degree would be odd opposite. How about B? Negative leading coefficient and even degree. Even, same, so the degree is even. You could also take this graph and then have a list of possible polynomials, and you could match this graph to the polynomial by looking for the one that starts with a negative number and has an even number as the largest exponent.